Hi everyone, this is about controlling the LED by using the Linux device driver model with procfs. For this you can see in the line number 7 the proc_fs.hr header file is required, and then sequence underscore file.h header file is required for the file operations. And then to write into the kernel buffers we need uaccess.h, that is for the copy from user. And coming down, so here we need a blink proc show. Okay, before that I will go to the actual structure. That is nothing but proc ops structure is required here, and here proc open is actually a function pointed to a function, and blink underscore proc open is defined. It's implemented in this file only. And for the reading, it's a sequential underscore read. It's from the implemented by the Linux device Linux. And for writing, I have written the blink write, and for leak and release is again used for by the file operations, sequential file operations. Coming to the proc open, you can see here this is a blink underscore proc open. It expects a inode pointer and then file pointer, and using a single open, just open the file and then call it the blink proc show. Blink proc show is used to display the kernel debug logs. So currently I am just printing the status. And then next is in the init. Okay, coming back to the init, so we have to create the procfs interface. That is the name I have given the file as LED blink, and next is these are the permissions. So read write for group and others, but not for the user and group, but not for the others. And then next third one is a null. You can create if it is any parent proc entry, you can give it, else make it like a null. And then finally you just pass the address of the proc underscore ops structure, that is they defined in the line number 99. And in the exit you have to remove this proc entry with the name LED. And coming to the blink write, so here this expects a file pointer and then buffer from the user side, and what is the size of that count of the buffer, and then finally we have L of t offset. So this is a right hander, this is a local buffer of the size 8, and I'm calling this copy from the user, so that whatever the values is getting, it's getting stored here. The count, actually I'm reading the 2 bytes, that's the reason I'm using a 2 from buff to local lbuff. And very first one is if it is a 0, then enable reset the enable as a 0, else 1. And next is second one is counter for the blink timer, so I have to convert it to a integer, so I used a k string to unsigned long from the user, since it is from the second element. So I just provide the buffless one, and count is only a 1, that is 2 minus 1, and it has to be converted to the decimal, and the result gets saved to the res, that is unsigned long. And finally I am using this timer value here, and same thing is being used in the timer, as you can see here. This is the timer, and earlier it was my milliseconds to the fees, of 1000, but now it is timer value multiplied by 1000. This is millisecond. And regarding enable, by default I have set it to 1, and if it is enable and status, then and set the LED to true, else clear it. So let's go and execute this. Already executed it, as you can see over here. So the connection says as it is, the 9th pin is ground, and 48th pin, that is pin number 21, is connected to the resistor, 1k resistor. The other end of the 1k ohm resistor is connected to the anode end of the LED. So now let's execute some commands. So I have controlled it. Let me run it as a super user, and then let me show the proc LED blink first. Actually list those. Okay, I think I need to list out only here. So you can see here the LED blink has been listed out. Now what I do is I just echo what is there in the LED blink. So it's 1, and I can run in the while loop also, so that you can hear actually while true do. Sorry, it takes some time. Cat proc LED blink, and done. So you can see it's a 0 and 1 continuously whenever LED is blinking. So it's 0 and 1, and yeah. So come out of that one. Now next is regarding controlling using echo. I can show you that echo, and then I will disable, and first one is a 0 for disabling, and the second byte is 0 1 for a timer. And if I enter it, hi, actually, okay, let me write this 0 1. That 0 is for disabled, enable equal to 0, and 1 is for timer. And see the debug message. You can see this enable equal to 0 and timer is 1, and LED is not blinking. Okay, now coming back, what I do is I will write and make it enable as a 1, that is a 1 2, in that 1 is enabled and 2 is for timer. So I just enable this, and if you see the D message, and you can see this enable equal to 1 and timer is equal to 2. So you can see every 2 seconds timer is happening and it's off. This is how actually we can control the LED using ProcFS. Okay, thank you.